So I wanted to show you a quick video on how to use Google Sheets to create a regression equation or a coalition of determination. Uh, and what that means is, well, it's been talked about in your lessons, but you're basically creating a scatter plot of all your data. So here's my data that I put. This is my X values and this is my Y values. And I'll tell you how to get to this Google Sheets in a second here, but just to kind of give you an overview of what I'm going to talk about here is we're going to create a scatter plot, but scatter plots aren't the best when you're trying to predict something. So and I'll show you that in a second here. But what you'll need to do is you'll just go to Google Drive. Let's see. If I just did a Google search for Google Drive, and then I went over to Google Drive, and then I went into, instead of going into Google Docs, instead of clicking new and doing a Google Doc, like a lot of times you will do in school, you're just going to click Google Sheets instead. And so then you're just going to have a spreadsheet here. And like I just showed you on the one I'd already filled out, this is your X value, which is going to be, you're going to list out here. And then this will be your Y value, which you'll list out here. And the difference with X and Y is that X is always your independent variable. Like it's not dependent on anything. Like the time and the years are not dependent on anything. They just are the years that go by. But then these are cases of malaria. And these numbers are completely dependent on which year you're looking at. So this is the year since 1900. So this would be the year 1900, and you had 28,000 cases of malaria, which, and that number 28,000 is completely dependent on the year 1900. In the year 1911, you have a totally different number, and that number is dependent on what year you're looking at. So that's what the difference between independent and dependent variables. And I'll show you that on the graph. The X is always the horizontal, and then the Y is the vertical. So you have your X values here, your time, your years, and then here's your whatever the data you're looking at, depending on what your project is. And then all you're going to do is you're going to highlight those with your mouse, and then you're just going to click Insert Chart, and you want to pick out what type of graph you want. We want a scatter plot, like I was saying before. So here's our scatter plot. I just clicked on scatter plot right here. And so these values are kind of all over the place. We have to figure out what's the best line to what the best fit for a line would be. And there's three different choices. You can either pick a linear line, which is just a straight line. You can do a polynomial or quadratic, which will curve. And then there's an exponential also that curves. They tend to start in one spot and kind of go up, or start here and go down. So we're going to see which one would be the best for our scatter plot, and that's going to be our regression. Well, we're going to find the line that fits the best, and then we'll have an equation for that line, and that'll be the regression equation. And so let's take a look here. We've got our style. We just did that. And let's go to customize. And so we're going to go to, let's see here, it's grid lines. Nope. Let me figure this. Okay, here we go. You want to click series. And then you're going to click the trend line. We're trying to figure out the best trend line. There's a linear line. That's not a great fit to our line here. But well, the best way to find out the fit is to show the R squared, which is the coefficient of determination. So if you come up here, you see that the R squared here is 0.178. You want that number to be close to 1, to the number 1. So we're at 0.178. So we're not super close to 1. Let's see if we can, and that makes sense because look, this line isn't really matching up, right? So let's try a different line. Let's try an exponential line. Okay, so this one, usually exponential lines are a little bit more curved than this, but this one is showing the best fit for this particular. And it's even worse of a fit because it's 0.153. So that's definitely not a good fit for our model here. Let's try polynomial. Okay, that looks pretty good. And look at this. The r squared, which is the coefficient of determination, is 0.966. That's very close to 1. And if you're at 1, then you got an exact match with your line in your regression equation. But we are very close, and that's the best we're going to do, because that's really the three choices. You could try logarithmic, but look at that. That's not at all close. It's really these first three that you want to check on. So the last thing you can do is actually find your equation for this line. And so we're gonna, right there, before it said custom, or it might have said none, whatever it says, you want to use equation. So now they have our equation up here. And the one thing that I don't like about this program is they should have a little line in between here, because your equation is over here, but then it all of a sudden, so your equation is 27,909 plus negative 8,100x plus 702x squared. That's it. This next thing, the r squared, we just looked at that. That's the coefficient of determination. That's not part of the equation. I don't know why they have that right smack up next to that equation. So just try to separate that out so that you can see that those are the two. They're separate. And the other thing is most of the time when you make an equation, you have your x squared value first, and then your x, and then your final number there. And so they kind of separate that out a little differently, but that's okay. We have our equation, we have our coefficient of determination. This is our regression equation. And now, because we have an equation, we can make predictions. These are the years since 1900. So you got 1900 all the way up to 1912, or I guess we have until 1913. But what if we wanted to know, what do we think is going to happen in 1917? Well, what we can do is we can plug in 17 for x here. So you'd want to put, you'd have to multiply 8,100 times 17 for this number here, and you'd have to make it a negative number. And in fact, it could just be this number minus this number here, but they put plus negative, but that's the same thing as just the whole thing is minus. So anyway, you're going to multiply 8,100 times 17 and subtract that number from this number, but then you also have to add this number, which is 702 times x squared. So you have to do x squared first. You always do exponents first in your equation, which you probably should have done that before this one. But anyway, you do 17 squared, multiply that times 702, and add that to the number you got here. And that's going to give you an estimation of what's going to happen and how many cases of malaria there will be in 1917. And that's why we do these. We want to have an equation, and if you just had these without this line here, if you didn't have a line that could fit an equation, you just have these scattered, before we had this line in here, we just had the scatter plot. You can't make any predictions based on just scattered numbers. You have to have an equation so that you can plug in your numbers to get an estimation. So you have to have an estimated regression formula, which is the estimation of line of your data set. And so that's why you're looking to see which kind of, up here we were looking to see which is the best fit here. The r squared value will show you which is the best fit based on which one goes to, or closest to 1, and then you get your equation, and then you can plug in any numbers you want to make predictions. So hopefully that makes sense. And if you don't have Microsoft Excel or a graphing calculator, that's okay. You can use this Google Sheets. So let me know if you have any questions, and hopefully